All right, so I kind of save classes for TypeScript because I think it's more clear cut for like their users. There are classes in JavaScript, but TypeScript I kind of feel like drives the point home why we're using them. So first off, a class is basically a way to organize data, just like objects. Except for a class, I kind of want to reuse the object. So if we remember like objects, right? We had like let's shadow the cat, and then we had all the properties of what makes shadow the cat. But it's kind of like annoying because like what happens if I have multiple cats, right? Like let I don't know Tabby, which is also a cat, and I have to type all this stuff out for every time I need a new cat because a cat has these properties, but like in my program, like let's say I'm making like a I don't know a pet store. Well, I'm gonna have different cats, like like in inventory. Let's say I'm a pet store, and I'm selling like animals. So I'm just like I have like lots of different dogs and lots of different cats in inventory. I don't want to type all this stuff out every time I have a new cat because that's going to be a lot. Okay, like I sell cats and get new cats, and it's going to be quite a lot of typing, a big mess. I would rather have something reusable. I would rather have something like a blueprint. Like, here is what makes a cat. And then every time I want a cat, just go ahead and go back to this blueprint and, make a new cat for me. That's what classes do. All right, so once that we start using them, you'll start to see, like, appreciate why classes exist. So the syntax is just class and then the name of the class. So I have an office, like an office management piece of software, all right, that I'm writing. And in my software, I have what's an employee. Okay, employees are a class in my software because my software will keep track of employee vacations and when do they start and who's manager, that sort of thing. So that I'm making like some sort of HR software. So it makes sense that in my HR software, there's a thing called employee. So what is an employee? An employee is something that has a first name, a last name, an employee ID, when they started the company, and whether or not they're currently on vacation. Right? These are properties of the employee class. Okay, which means if you are an employee, then I have this information about you, which makes sense, right? Because I need this information to like do stuff in my software. Now let's go to the constructor. Okay, classes have constructors. Remember, I want to reuse an employee. I have like 500 employees, like all with different names and different start dates, and some people are on vacation and some people are not. So I need to construct or create a new employee for each person I have. And so when I construct an employee, what information do I need about that employee to fill in? Well, I need to know what their first name and last name and employee ID and start date and on vacation. So the constructor, okay, is a function that's run when we create a new employee. I provide the constructor this information about the employee, and then it sets all my variables for me. Couple small details. If you have a property of a class, then it must be set somewhere in the constructor. So for example, let's say I forgot to do passing on vacation to constructor. You see how it's mad? Okay, so I'm going to do this. Like if I get rid of that, you see how TypeScript's mad? Property on vacation has no initializer, and it's not definitely assigned to the constructor. Basically saying, hey, you've got this property on vacation, but it's not set to anything. You need to like give me a value somewhere in the constructor. So that's why for each of these properties, notice I have a constructor for it. So in the constructor I pass in the first name. I will set this refers to this object. So this always refers back to its container. So this is inside the class employee. So this is always going to refer to that employee. So when I create a new employee, that employee's first name is what I pass in to the constructor. Same with last name and employee ID. We'll make this make sense in a second. Okay, your classes can have built-in functionality. They can have methods. Okay, methods basically is a function related to a class. I try to make certain I use the right nomenclature to say things are methods versus functions. But in some computing languages they use different words. Basically, you can just think of it like if you hear the word method, it's a function attached to a class. So that means, for example, I have an employee class, and an employee I can get their full name, which is their first name plus their last name with a space in the middle. I can also get time with the company in days. Like, how long has this person been with the company? Because that's going to be information I'll need to say whether or not they can go on vacation. All right. So we also have date, which is we're going to start working with dates now. I'm going to teach you guys how to do that, and so we can learn a little bit about it now, just some basic stuff. The date, as you can see, is green, right? This is a built-in class. See, we made a class employee. They're also built-in classes for JavaScript we can use. So date's one of them. If you do new date, see this new keyword? Okay, this is instantiation. Okay, instantiate, make a new date. So it goes says, okay, cool, make a new date. Well, what's the date? The default is the current date and time. So if you do new date like this, it will be equal to the current month, day, year, and time on your computer. Now, the reason I'm constantly saying on your computer here is because if you do run this program on a different computer and that computer has the wrong time, it will take the time from that computer. It doesn't magically know what time it is. It goes to your computer and says, hey, what time do you say it is? So just keep that in mind. All right, we'll go into this more in how this logic works, okay, in a bit. But for right now, you just need to know that new date. Okay, we're going to use this date object now to work with dates, not strings, not numbers. We use this date class here to work with dates in JavaScript. Couple little small things we can learn about date right now. Let's see, I'll show you when we get to the constructor. All right. So we've got this base class employee. This is our base class. But you're saying, Jonathan, we have different kinds of employees in our company, right? Cool. For example, we have managers. Class manager extends employee. If you remember from the interfaces, I talked about extending being inheritance, right? We had it here for interfaces. Same thing with classes. What it means is the manager class will inherit all the methods and properties from the employee class. So that means a manager has access to all these properties here. Okay, and he also has access to all the functions. So a manager I can also get the full employee name for a manager and how long they've been with the company. Okay, just like I could with any other employee. The difference, though, is managers can make bank deposits and approve vacations. So that's the thing special about a manager that other employees don't get to do. This is why we're using inheritance. Okay, inheritance is a way to sort of think about what's the same and what's different. So what's the same and what's different. This is a core programming concept, right? You're looking at your program and like, what's the same and what's different? If it's the same, I'd like to consolidate it in one place. So all the employee functionality and information is going to be stored in the employee class. Manager will inherit from employee. It will get all the employee stuff for free, and then manager can sort of differentiate itself for what specifically a manager does. So, for example, a manager can approve vacation or make bank deposits. Now, as far as the constructor, notice how I'm still bringing in the first name, the last name, the employee ID, just like I did up here for the employee class. So all that stuff, I have to still have all that information. Plus, I also have whether or not they can make bank deposits and whether or not they can approve vacation. Okay, let's learn super, line 48. What super means is, hey, go to the parent class. Okay, that's what this keyword means. Hey, go to the parent class and do this. So for the constructor, what I want to do is I want it to go to this constructor on line 12 and run this. Because it's the parent for all the properties like first name, last name, employee ID. All right, so go do that. When you're done, then I'll handle the stuff that's specifically for the manager class. Okay, super refers to the employee parent class. It says go here to this constructor and do this. Remember, constructors are functions. Okay, so it will do what it needs to do for the parent class, and then we do what we need to do for the manager class specifically. Okay, this is a pattern. So just go over this a couple times so you get it, but super means go back to the parent. Now, managers have different functions than other employees. For example, a manager can approve employee vacation. It takes an employee as an argument and returns void, meaning it doesn't return anything. Okay, so I have some logic. First, I check to see if the manager can even approve a vacation. Some managers can approve vacation, some don't. All right. If they can't, they'll give you a little thing that says, sorry, I can't approve your vacation. If the employee is already on vacation, then why are you coming to me to get vacation? You're already on vacation, go away. Okay, so if the employee is on vacation, it will say, I'm sorry, you're already on vacation. Okay, then if the manager can approve the vacation and the employee is not currently on vacation, then we need to check to see, has the employee been with the company for 90 days? If the employee has not been with the company for 90 days, sorry, like, can't approve you for vacation, you haven't been here long enough. Otherwise, we'll say vacation's approved. So this functionality, approve employee vacation, makes sense to have for the manager class. It does not make sense to have for the employee class, so that's why it's here and not in the parent. So you see how I'm separating functionality based on like need to know? So managers will have functionality specifically for managers, but they get all of the stuff for employee for free. I still need to know the manager's name, and I still might need to know how long the manager's been with the company. Alrighty, so I made another class called Code Monkey. Okay, these are the people who just like do code and like sling code. That's what they do. They're also employees. That's why they extend employees. So they also have a first name, a last name, an employee ID, a start date, and vacation. But what's different is they have whether or not they enjoy Fritos, how much Mountain Dew they consumed, and how much energy they have left to code. Okay, that's different than a manager. Okay, a manager does not have those properties. A code monkey does. Okay, but you see how you see the convenience now, like because they're an employee, all this stuff, okay, I get for free. I get all these properties, and also I can get the employee full name and how long they've been with the company. So we do the super, first name, last name, etc. And then this stuff is for code monkeys. And code monkeys can consume Mountain Dew, okay, to give them more energy, and they can write code. Notice how I'm using this .get employee full name. Code Monkey, you don't see get employee full name anywhere because employee full name is in the parent class. But because Code Monkey inherits from employee, it gets this function. Anything that inherits from employee has these properties and this functionality. Now, that was a lot to go over, so try to go over the code as best you can. I exported the stuff here. Let's try to see this at work now. So now we're trying to see, okay, Jonathan, that was very complicated. You have like parent classes and child classes and functions and properties and your super keyword, and then you threw dates at me. Okay, here's why we actually do object-oriented programming. Your program has to do some job. Approve vacation, keep track of employee time and travel, do expenses. Okay, the whole point of writing software is to perform work for a business or for fun. Okay, so software has to perform some kind of like job. It has to be useful in some way. It's really nice to be able to inside the code sort of like model a real life situation so it's easier for us to think about. So let's create some managers and some code monkeys. Let manager1 equals new manager. I'm instantiating a new manager, and now you'll see the constructor. Okay, I'm going to put put this over here. Put them side by side a bit. So notice how the constructor, I'll just put the signature up to here so you guys can see it. Let's copy the whole thing actually. All right. I'm going to make this very, very blatant. New manager. The first thing is Michael. Well, notice how in the constructor, the first argument is first name, right? So this manager's first name is Michael. This manager's last name is Scott. Employee ID. Start date. Whether or not they're on vacation. Okay, so this first part up to here is the constructor from the parent class. Notice how it's in order. The first name, last name, employee ID. So that means that this manager, he follows the same pattern, okay, as other managers, but we can sort of give him specific information for him. His name is Michael Scott. He started in January 15th, 2010. Okay, so for dates, let's learn a little new thing about dates. When you do new date, you can give it 3 arguments: year, month, day. In JavaScript, the months are 0 index, so January is 0. Okay, so this date is January the 15th, 2010. Now, this person is a manager, so up to here, all the properties from the parent class, these 2 properties are from the manager. So now you can kind of see how the constructor works, right? So the constructor basically says, take in this information and then set the information of this manager. So you see I have 2 managers, right? Manager 1 and manager 2. They both follow the same pattern. First name, last name, employee ID, start date, blah, blah, blah. But they're different managers because they have different data. This guy's name is Michael Scott. This one's William Lumberg. So in my code, I could have different managers with different pieces of information, but they're all managers, right? I know what information they have. They just can have different information based on the individual. Same thing with code monkeys. Okay. Their constructor, you'll notice is different. They have the same first part. This part's the same. First name, last name, employee ID. This part's the same in all of them. Same. The only part that's different is whether or not is the next part, which is if you hover over this, by the way, it will tell you the order of in the constructor. So first name, last name. So they have whether or not they enjoy Fritos, Mountain Dews consumed, energy to code. Okay, this is the first step in using object-oriented programming. Okay, so in my program, there are 2 managers, one named Michael Scott, one named William Lumberg, and 3 code monkeys, Byron Smith, Mona Lisa, and Bart Simpson. And you see how they have different start dates. They have different names, but they all follow a pattern, a predictable pattern. Now let's kick it up a notch. I'm going to go ahead and comment some of the stuff out. Okay, now we go back into why do we have functions. Manager 2, approve employee vacation, code monkey 1. So what this is doing is Manager 2, William Lumberg, will run this function, approve employee vacation, with code monkey 1 as the argument. Let's go back to approve employee vacation. This function exists in the manager class, which makes sense. Managers approve vacation. Notice how, however, that code monkey 1, let's do code monkey 1 dot approve. See how I can't even do that? Approve employee vacation. TypeScript yells at me. Code monkeys cannot approve employee vacations. Managers can. So code monkey does not have this function. Manager does. So that's very good because that makes sense. I don't want a regular employee approving vacation. I want a manager to do it. That's why we separated those functions out. So a manager can approve of employee vacation, and we'll take this code monkey as an argument. So remember, let's look at code monkey 1. He's been with the company. He started on December 10th of 2022. He's a very new employee. If you haven't been with the company for 90 days, we can't approve your vacation. Let's see what happens. npm start. Okay, am I in the right? Oh, I gotta go the right thing. Oops. So I'm gonna right click, open the integrated terminal. Okay, cool. npm start. Okay, William Lumberg says, I'm sorry, Byron Smith, but I can't approve vacay. Right? So this manager, okay, cannot approve vacay for this code monkey. Now let's switch it up. Okay, why can't manager 2 do that? Because see how it says false here? Let's go over the last one. The last thing is approve vacation. It's false. So this manager cannot approve vacation, but the first one can. So what happens if I do this? Manager 1, approve employee vacation, code monkey 1. Now let's see what happens. I'm going to comment this out. Oops. Click here first and comment it out. Now, this manager is Michael Scott. He says, I'm sorry, Byron Smith, you haven't been with the company 90 days. So I have different functionality. They're both managers, but because I use this new keyword, new manager, I have different managers with different levels of approval. So now, one manager can approve vacation, one manager cannot, right? This employee cannot go on vacation because they haven't been with the company for 90 days. Let's run that through all the employees. Okay, so the first employee, CodeMonkey1, has not been with the company for 90 days, so he can't go on vacation. The second one can, okay? And then the third one, Bart Simpson, is already on vacation. But do you see how, like, all the functionality of my app changed based on the information for each CodeMonkey? So I can do all sorts of complex things with my program now. I can say, okay, this manager can approve vacation. This manager can do bank deposits. This employee can go on vacation. This employee cannot go on vacation. I have all these rules and functionality I can add, and now it's very easy for me to kind of like think through what I want to do because this is very real world. I have managers, I have code monkeys, right? These are the things that they can and cannot do. These are the rules, the business rules I've set up. Okay, these are all this information, and it's nice and packaged. Okay, this is the core of object-oriented programming. We have these objects, and their entire point is for them to interact with one another. I want all the objects with all their information and their functionality to be able to interact with one another and do like different business tasks. So that way I can improve, do things like approve vacation. So if I'm gonna run with everything. Okay, so it also helps me second. So for example, code monkeys can consume Mountain Dew. Notice how managers cannot. That function doesn't even consume Mountain Dew, does not exist for managers. So it helps to differentiate between managers and code monkeys. Okay, and so my app can do whatever the heck I wanted to do, and that this is the core like reason why we're using object-oriented programming. Now it gets way more complicated over time because we have complicated like business needs. But the main point I want you to get is new class constructor. This part is the constructor. What information do I need at the beginning to like make it so I can use it? So we have that's for the constructor. So this what's happening here on line 6, what I'm highlighting is what's happening on line 45. That's what this is. You are passing all this stuff in, all these values. Okay, you are constructing or creating a new manager. Each manager follows the same pattern. They have a first name, last name, whether or not they can make bank deposits, but the individual is different. This is the point of classes. I can have the same pattern, but differentiate them by individual. We use inheritance. Okay, so for example, manager extends employee. CodeMonkey extends employee. So that way we can put all certain pieces of code that's the same into one place. Code monkeys and managers all have first names, last names, employee IDs, start date, and whether or not they're on vacation. All of them. So I'm going to put all of the stuff that they share into one superclass or parent class. You'll hear the term superclass sometimes. All right? They'll have a constructor, and then they'll have functionality that is there for all employees. And then by using inheritance, I can sort of differentiate what a manager can do and what a code monkey can do. All right, this is very. This is going to take a little while to get for some people. So watch this video again, right, and look at the examples in the GitHub, so that you can try to sort of start to absorb this because we're going to start doing some object-oriented programming more and more as class goes on.